Hello everybody, I hope everybody is doing fine. So this is me and welcome you today in this lecture. Today we will be studying the second topic of this chapter of light chapter. In the previous lecture we have studied about the plane mirrors and some other important information about light. But in this lecture we will be studying about the spherical mirrors. Spherical mirrors. What we are going to discuss? We are going to discuss spherical mirrors. Okay, so let's move on to the next slide. Okay, so before starting this particular lecture, I want you to know that what is a plane mirror. We have already studied about plane mirror in our lecture first, but let me give you a quick recap. Plane mirror is a flat, smooth, reflective surface. A plane mirror always forms a virtual image that is upright and of the same shape and size as the object it is reflecting. So here it is saying that, for an example, let's suppose this is your plane mirror, okay, and this is you standing here and this is your image. So if the height of you is h, then the height of image will also be h. Okay, if the distance between you and the mirror is d, then the distance between you and the distance between the plane mirror and the image will also be d. Okay, and the type of the image is virtual. In this case, in the case of plane mirror, the type of the image is virtual. Now, why I am telling you all these things? Because we have another mirror to study, and that is spherical mirrors. So spherical mirrors are different from plane mirror because these are the curved mirror. These are the curved mirror. These are like this. This is our spherical mirrors. In the back side, we have done some type of coating and the light is reflected from this surface. And I hope I don't need to explain you again what is reflection because we have already studied reflection in the previous lecture. So by this surface, the light is reflected. So this is a spherical mirrors. There is another type of spherical mirror also, and that is this. This is also a spherical mirror. Here in this case, we have done the coating on this side, on the inner side of the spherical mirror. So light is reflected from this side. Now light is reflected from this side of the mirror. So these type of mirrors are also spherical mirrors. Okay, so I hope you got my point. Now let's try to understand what are the properties of spherical mirror. So a spherical mirror is a mirror that has a consistent curve. You can see there is a consistent curve and a constant radius of curvature. Here you can find a radius of this mirror. I will be explaining you this in the later part of this lecture, that what is a radius of curvature. There are some other terms also which is yet to be explained. I will definitely explain in the later slides. For now, you just need to understand that there is a constant radius of curvature of spherical mirrors. But if I talk about the plane mirror, then there is no radius of curvature. But in the spherical mirrors, there is a radius of curvature. And if I talk about the types of the images, because in the plane mirror, we always find a virtual image. There will not be a real image in any case. But if I talk about the spherical mirrors, then the types of the images can be either real or virtual. It means it can form both the images, real images as well as virtual images. Okay, it will be dependent of the distance of the object from the spherical mirrors, like where you have placed the objects. This will be depending on the image. So now spherical mirrors are of two types, concave mirror and convex mirror. So I will explain these two terms in the later slides. So let's move on to the next slide. So now at this slide you can see the clear images of the concave and convex mirror. So this is our concave mirror and this is our convex mirror. Okay, and what is the difference between these mirrors? I have already told you in the previous slide that in convex mirror this side is reflective surface. This side is reflective surface, and I don't need to explain you again what is a reflective surface. Okay, because the reflective surface is the surface from where a light is reflected, and here in this case, in the case of concave mirror, the light is reflected from the inner side of this spherical mirror, means from this side. So this is the basic difference between the spherical mirrors. Okay, now in the upcoming slides we will be studying about some terms related to the spherical mirrors. Okay, so let's go to the next slide and let's try to understand what are those terms. So guys, in this slide you can see that there are some terms written here: focus, radius of curvature, center of curvature, pole, principal axis, and focal length. So what are the meaning of these terms? So let's try to understand what are the meaning of these terms. First we will be studying about focus. What is a focus? So to explain this focus, let me give you a very basic example by the help of this image. So this is an image, and here you can see this is a spherical mirror. Now I have a question for you, that what type of spherical mirror it is. So you will simply say, sir, this is a type of spherical mirror and the type of spherical mirror is concave. So this is a concave mirror. Now if I ask you why this is a concave mirror, then your answer will be because the light is reflected through this part of the mirror. This is our inner part. The light is reflected through this inner part of the mirror. That's why this is a concave mirror. Now, if I ask you that what is a focus? So, to understand focus, I need to give you a very simple example. Let's suppose this is a ray which is parallel to this line, which is in black color, and this line is known as principal axis. Let me write it here for you, principal axis. Now why it is principal axis? Because this is a line which is connecting this point C and this point P. So the line which connects the point C and point P is known as principal axis. Now you can ask me, so what is the meaning of this point C and this point P? So this point P stands for pole, and this refers center of curvature. Now you can ask me, what is center of curvature and what is pole? So I will tell you these two terms later, because now we are understanding focus. Okay, so I will be telling you center of curvature and pole later, but for now just understand that the line which connects C and P is the principal axis. Now these lines are parallel to the principal axis. These lines are parallel to the principal axis. And the point where these rays are meeting after the reflection is known as focus. At this point they are meeting, that's why this point is known as focus. I hope you got my point. Now, let's understand the second point, and that is radius of curvature. Now what is radius of curvature? It is very simple, because here we are studying about the spherical mirrors. What we are studying is spherical mirrors. Okay, so here you can see a sphere. You can see a sphere. So this mirror would have been a part of a sphere. Okay, so let's suppose this is your sphere. I cut this part from here, this part, and I got this spherical mirror. So there would have been a radius of this sphere. Let's suppose that is r. This is a radius of this sphere. So this radius will also be the radius of our spherical mirror. Okay, because it was also a part of a sphere. That's why the sphere also had a radius. That's why our spherical mirror will also have a radius, and that is r. Now let me tell you what is the center of curvature. So all spheres have a center. All spheres have a center. That's why our spherical mirror will also have a center, and that is point C. Okay, that is point C. So I hope you got my point. What is the meaning of C? This is the center of the sphere. Okay, and the radius, the line connecting to the center to the part of the, or you can say to the parameter of the spherical mirror. So this is our radius, this is our point C. Now let me tell you what is pole. So the midpoint of this sphere, of this spherical mirror, is pole. This is a spherical mirror, and this midpoint is pole. And the line which connects center and the pole is known as the principal axis. I already told you that. Now, focal length. So the distance of focus of this point focus to pole is known as focal length. Okay, so let's suppose this is point F and this is point P, and the distance between these 2 points are known as our focal length. I hope you understand all the terms written here: focus, radius of curvature, center of curvature, pole, principal axis, and our focal length. Okay guys, so now after understanding these terms, let's move on to the next slide, and let's try to understand what is there for us. Okay, so now after having the understanding of these terms related to light, we will try to understand how an image is formed through spherical mirrors. How an image is formed in spherical mirrors. It is very important. Okay, because in this when we complete this chapter, then we will solve some numericals, and to solve those numericals we should have a very good understanding about these terms. Okay, so let's try to understand what is the representation of images formed by spherical mirrors using ray diagram. Okay, and before telling you this, let me write a very important relation between the focal length f and the radius. And what is this relation? The focal length is just half of the radius. Okay, let's suppose this is your spherical mirror, this is focal length f, this is our point P, and this is our radius. Okay, what is the radius? Let's suppose this is point C and this is for pole P, and the distance between center and P is radius. and this radius is just double of our focal length. This is our focal length, distance between this point F and P, and this radius is just double of this focal length. Okay, and you can write it inversely that the focal length is half of the radius. Okay, both the statements are correct. Now guys, we would be studying about the ray diagrams. Okay, because image formation, to understand the image formation, you need to have a clear understanding about the ray diagrams. So this is our image first, and in this image what is happening, the ray is coming parallel to the principal axis. This is principal axis, this is our principal axis, and this is the ray coming parallel to the principal axis. And in the previous slide I told you that the ray which goes parallel to the principal axis always cross the point F, or you can say always meet the point F. So it will meet point F. Now this is the case of a concave mirror. And this is our convex mirror. Now you can ask, sir, what will happen in the case of convex mirror? So this is our convex mirror, a ray already going parallel to this principal axis, coming parallel to this principal axis. After the reflection, it is going back in this direction. So what we will be doing here, we will increase this in the previous direction. Okay, we will increase this in the back direction. So at this point where it is appearing to be meeting, this point is known as focus. And in this case here the rays is not actually meeting. We are increasing it, or we are assuming it to be meeting at this point. They are not actually meeting. So that's why this point is known as focus. That's why this point is known as focus. I hope you got my point. Now the normal to this line will pass the center. The normal of this line will pass the center. And here in this case, the normal of this line will also pass the center. You can increase this line in the previous direction, and this will be appearing to be passing center. This is our center of curvature. Okay, so I hope you got it. Now let's move on to the next slide. So in this slide, okay, so before explaining this, I want you to know that whatever we are learning here, these are the rules which will be used to form an image of an object. Okay, this will be used, these diagrams will be used to form image of the object through spherical mirrors. So that's why to understand or to have a clear understanding of these rules are very important. Okay, so this is our second rule. What we have learned in the previous slide was first rule, and this is our second rule. So according to this rule, what happens if a line crosses this point F, and after the reflection this line will always go back parallel to the principal axis. This is just opposite rule what we have studied in our previous slide. In previous slide what we have studied, that whenever a line going parallel to the principal axis, after the reflection it goes back crossing the point F. But here I am telling you that whenever a line or whenever a ray crosses point F will become parallel to the principal axis. So these two laws are just opposite. Now what will be the case of a convex mirror? So in the case of convex mirror, what will happen? This is a line going or appearing to be crossing this point F, because it is not actually crossing point F, but it is, if you increase this ray in this direction, then this is appearing to be crossing, or this is appearing to be crossing point F. So what I had told you in the case of concave mirror, that whenever a line cross the F become parallel to the principal axis. So this will also happen here. Whenever a line appear to cross point F will become parallel to the principal axis. So this is our principal axis, the line connecting to the pole and the center of curvature, principal axis, or I can write it in short form PA. Okay, and in the upcoming lecture I will write it PA, so you will understand what I am talking about. So this will become parallel to the principal axis. This is our second rule. Now let's move on to the next slide. So this is our next slide. Now here, this is rule third. Till now we have learned two rules. This is our rule third, and according to this rule, what happened, whenever a line passes through the center, we'll go back crossing the center again. And in the case of convex mirror, the line appearing to be crossing the center will go back again in the same direction where it was coming from. So let's suppose this is our ray going in this direction. After the reflection, it will again go in the same direction. I hope you got my point. And let me give you some extra knowledge. Okay, what is some extra knowledge? We have studied that whenever you connect a line from a center, then this makes an angle of 90 degree, okay, from the surface. Okay, and this will also the angle of 90 degree from the surface. Now let's suppose this is our surface and this is a line, this is a ray coming like this. Now what is the angle of incidence in this case? The angle of incidence in this case is 0, because it is parallel to the normal. Okay, what is the normal? Normal is a line which is making the angle of 90 degree from the surface. So this line is also making the angle of 90 degree. So this is parallel to the normal. That's why the angle of incidence is 0. Now if the angle of incidence is 0, then according to the laws of reflection, we knew that angle of reflection is always equal to the angle of incidence. Angle of reflection is always equal to the angle of incidence. So here the angle of incidence is 0, then the angle of reflection will also be the 0. So the line will also make the ray which is going back will also make the angle of 90 degree. So that's why both the rays which is coming and the ray which is going back will always be in the same line, or you can say both are the parallel rays, because this will also make the angle of 90 degree. So that's why here in this case you can see then the line which crosses center or which going back and passing through the center will also go back through the center. Okay, now the convex mirror, I already told you what happens in the case of convex mirror. The line appearing to be crossing the center will go back again in the same direction. Now let's move on to the next rule. So guys, according to this rule, this is our rule number 4. So according to this rule, what will happen that whenever a ray strikes on a concave or a convex mirror obliquely, okay, like obliquely, you can call it obliquely. In this case also, you can call it obliquely. At its pole, this is our pole P, this is also pole P, it is also reflected obliquely, making the same angle with the principal axis. Okay, so this will again go back in the obliquely. If it is coming obliquely, then it will again going back obliquely. You can also write it here obliquely. Now guys, why it is happening? Because I already told you that angle of incidence is always equal to the angle of reflection. This rule will always be applicable. This is angle of incidence, and that is angle of reflection. So angle of incidence and angle of reflection will always be the same. That's why if a ray strike on point P, okay, and coming obliquely, then it will again going back obliquely, and the angles are always equal. Okay, so this is our rule number 4. I hope you got my point. Okay guys, so till now we have learned about the spherical mirrors, all the concepts related to the spherical mirrors and the rules to form the image formation. I hope you got whatever I have told you. I have also explained some very important terminology related to the spherical mirrors. So I am ending this lecture, and see you in the later lectures. Bye bye.